So this question was, I think it was from 2016, if I remember correctly. This one, you'd be very lucky if you got this nice, simple, easy area volume type question here. It's only got a little bit to do with volume. And in fact, it really doesn't include any of the BC only stuff. So like this question was actually also used on the AD test this year, or that year that it was on. I think it's in 2016. So the first thing is they want to find the average value of the radius of the funnel. So that should be pretty straightforward. And we're talking about the average value of something. So basically, we're talking about the average value of this continuous function. The average value of a continuous function is just the mean value theorem for integrals. So it should just be 1 over b minus a, since we're going from 0 to 10, of the integral of the radius, 1/20th, 3 plus h squared, dh from 0 to 10. And this is 1/10th, this is 1/20th that you can pull out. So we got 1/200th. And the integral of 3 is 3h, and the integral of h squared is h cubed over 3 from 0 to 10, which gives us 1/200th of 30 plus 1,000 thirds minus 0. And whatever that comes out to be. So what is that, 1,090 over 600, it looks like. Or 109/60 inches. Everybody good there with part A?
Yes.
1 point for the setup, 1 point for the antiderivative, 1 point for the answer. All right. Cool. Part B, find the volume. The volume of the funnel. Well, if we slice this thing horizontally here, then the cross sections should be circles. And so it should just be pi times the radius squared. Our radius is already in terms of h. This has a thickness of dh. So it should just be pi times our radius function squared, integrated from 0 to 10. So we'll have pi 0 to 10, and now I already forgot what was our radius function. 1/20th out in the front, so I'm going to put that as a 1/400th here, and then it's just 3 plus h squared dh. Note that I made sure I squared that 20 out there. And we'll distribute this out, pi over 400. 3 plus h squared is 9 plus 6h squared plus h to the 4th dh. And that ought to be, I don't know why I put an equal sign there, that ought to be pi over 400 times 9h plus 2h cubed plus h to the 5th over 5 from 0 to 10. Arithmetic's a little bit of a pain there, I suppose, but other than that, pretty straightforward. 90 minus, that's a plus, 90 plus 2,000 plus sorry, over 0 is 100,000 over 5. And minus 0. And I just simplify that out. So 100,000 over 5 is 20,000. 22,090 pi over 400, or 2209 pi over 40 inches cubed. And I don't know if that reduces anymore. Probably not. Well, definitely not. So prime factorization, that's 2 cubed times 5, and 2 and 5 definitely don't go into 2209. So 1 point for the right integrand, 1 point for the right integral, 1 point for the right answer. Any questions there on B? All right, part C. This funnel here has now got liquid draining from the bottom. Talking about the instant when the height of the liquid is 3. We know that the radius is decreasing at 1/5 of an inch per second. And we want to know what's the rate of change of the height of the liquid with respect to time. So that's just a take our R function and take the derivative of it on both sides with respect to t. So we'll say dr dt equals, what do we have there, a 1/20th, right? And then the 3 goes away. This just becomes 2h dh dt. And so what did it tell us? It told us dr dt, the radius of the liquid is decreasing at 1/5 of an inch per second. So dr dt is negative 1/5. So we'll just plug that in. Equals 1/20th times 2. And what's the height we were talking about there? When the height is 3, so just put it at 3. And let's see, that becomes negative 2/3 equals dh dt would appear. And I don't know if it asks for units or not, but that'd be inches per second. And that was 3 points. 2 points for correctly doing this implicit differentiation with the dr dt and the dh dt, and 1 point for the final answer. And doesn't ask for units, but it's always, always good to have units. Any questions on that one? You miss related rates. Yeah, I mean, there's related rates on the test, maybe someday. We'll do some related rates at some point, maybe, I don't know. All right, give me 1 second. I gotta go let my dog out. She's whining at the back door. I don't really need her to do anything all over my floor. So think about how much fun this problem was, and I'll be back in 30 seconds. All right, sorry about that. Okay, so for part A, what are we looking at here? We got 2 curves, r equals 3 and 3 minus 2 sine 2 theta. So obviously r equals 3 is the one that looks like the semicircle there if we're talking from 0 to pi, and then r equals 3 minus 2 sine 2 theta is this other funky looking one. So R is the shaded region that is inside r equals 3 and inside 3 minus 2 sine 2 theta. So we want to find the area of R. So, and in order to do that, we can take a look at the quadrants separately. So if we were to look at just quadrant 2, we can see that that would definitely be just a quarter of a circle with a radius of 3. So for part A, we'll have 1/4 of pi times our radius squared guess I should write 3 squared. And then, so that's quadrant 2. And then plus, and then we'll do the integral of 1/2 of the outer radius squared from 0 to 5 or 2, so of 9, and then minus the inner one. So and this is calculator one, so your calculator can tell you what you end up with there. Oh, why did I do that? That's not right. Just the inside of that one. It's not the for some reason I was thinking it was the region between the circle and that curve, but it's not. It's just the curve itself. So 3 minus 2 sine 2 theta squared. Sorry about that. And then would that come out to be in your calculator? .708. There's a half out in front because the area of a polar region is always 1/2 r squared d theta. .708, Darius. Sounds good to me. 1 point for the correct integral, 1 point for the correct limits, 1 point for the correct answer, adding the 1/4 pi to it. And if you hadn't just noted that that's just the, hopefully you should have just noted that that was just the semicircle. So yeah, there's no other good way to do that. So everybody good there with part A? Molly, you good there? I know you'd asked a question on that, so yeah, okay. All right, part B, we want to find the value of dx d theta for the 3 minus 2 sine 2 theta curve at theta equals pi/6. So to find dx d theta, we need to figure out what x is. And as we know, x is always equal to r cosine theta, which in this case is 3 minus 2 sine 2 theta times cosine theta. And so dx d theta will just be the derivative of this. You can distribute it through if you want, or you can just use the product rule. If it's going to use the product rule, you still have to use the product rule if you distribute it through anyway. So we got 3 minus 2 sine 2 theta times the derivative of cosine plus cosine times the derivative of 3 minus 2 sine 2 theta, which should be -4 cosine 2 theta. And we wanted to evaluate that at theta equals 5/6. And I don't know why I'm writing all of this out because I forgot that this was a calculator problem. What did that come out to be approximately? So you could have just plugged this, the derivative of this at pi/6 into your calculator. That's what you should have done. Directly from the 3 minus 2 sine 2 theta times cosine theta. Looks like they got -2.366. And if this was not a calculator problem, you still should have been able to do this, right? 3 minus 2 times the sine of pi/3. So 3 minus 2 root 3 over 2 times negative sine pi/6 plus cosine pi/6 times -4 cosine of pi/3 And you would have gotten, whatever that comes out to be. Negative 3/2 plus root 3 over 2. What's that? Minus 2 root 3 over 2, so minus root 3. So negative 3/2 minus root 3 over 2. If you didn't have a calculator for some reason on this question, but you had a calculator, so negative 2.366 is good. Any questions or issues there with that one? Everyone's good there? Oh, points on that one. 1 point for having the correct expression, 1 point for the final answer. Okay, I'm waiting. Oh, and I'm no longer waiting. Okay, I was told to wait, and then I was told nuvum. Nuvum. I assume nuvum means never mind. So we're gonna go with wait nuvum. All right. Part C asked us, says the distance between the two curves changes. Obviously, the distance between them changes from 0 to pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. So we'll write an equation to represent the distance between them. Distance between them ought to be the distance between the outer function and the inner function. So the outer function minus the inner function. So we'll call it, I don't know, about capital D for distance. The distance ought to be the outer function, which was just 3, just the circle, minus the inner function. So minus the quantity 3 minus 2 sine 2 theta, which is 2 sine 2 theta. And what did it ask us to do about that? It just said find the rate at which that distance is changing. So we'll just take the derivative of that with respect to theta. So, and we wanted it, what was it, pi over 3, I think is what it said. Is that right? So derivative of 2 sine 2 theta is 2 4 cosine 2 theta. Evaluated at theta equals pi over 3. Cosine of 2 theta is cosine of 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. And so we get negative 2. 1 point for having an appropriate expression for the distance, 1 point for the answer. Good or no? Any questions on that? Everyone's good? All right. Part D says a particle is moving along the curve r equals 3 minus 2 sine 2 theta, so that d theta dt equals 3 for all times t greater than or equal to 0. Find the value of dr dt at theta equals pi over 6. So we are given d theta dt, we need dr dt. This is clearly a nice little related rate, just like what you guys are missing, Aiden, Nick, you guys are missing related rates. Here's some more related rates. So our curve is r equals, oh, we got it here. Our curve is r equals 3 minus sine 2 theta, right? So dr dt equals negative 2 cosine 2 theta d theta dt. And what did they give us? They gave us d theta dt is equal to 3. So this will be dr dt equals negative 2 cosine of 2 times pi over 6.
Mr. Bachelor, it's 3 minus 2 sine 2 theta.
3 minus 2 sine 2 theta. Oh, man. All right. Guess I should write the functions down properly if we want to get the right answers. Now I forgot. What was d theta dt? It's 3, is that right?
Yeah.
Okay. And so we got cosine of 5 or 3, which is a half. We got negative 4 times a half times 3, which gives us negative 6. So 1 point for the answer and 1 point for correctly taking your derivative with respect to t of everything. Good or no? And again, you have a calculator, so if you wanted to evaluate all this stuff out on your calculator, you could. I mean, none of this problem required a calculator, except that the first A and B they gave calculator approximations for their answer, but you should have been able to do all of it without a calculator anyway. So, everybody good there with that one? Okay, I'll assume that's a yes. So let's take a look at this one, another calculator one here. This was the last one I asked you guys to do on your own, right? Okay. I'll assume that's a yes.
Bachelor, there's people typing in the chat.
Oh, yeah. Look at that. Normally it notifies me that people are saying things, but they're not. Well, okay, what did, oh, yeah, Nick, 2 sine 2x, yeah. And then Delphine told me, yeah, look at that, okay. Why do we not find the x and y functions and do dy d theta over dx d theta? For part D, is that what you're talking about, Nick? Yeah, well, I mean, there's no particular reason to do that because it's not asking us to find, like, I mean, dy dx, right? To find dy d theta, dx d theta. Those things find us the slope of the tangent line. We're not asking for the slope of the tangent line in any of it. We just want to know how is the r value, the distance from the origin to the function itself, changing with respect to time. And so you can just take your r equals whatever theta equation and differentiate with respect to t. It's just like a related rate question. Just like what you and Aiden were missing, related rates. Yeah. Sorry, I don't know what's going on. My laptop's acting weird today, so apparently I have to like close the chat out. I don't know if can you guys see the chat when I open it up? Like I have it open now. Can you guys actually see it like on my screen sharing or no?
Nope.
No, yeah, I didn't think so. Yeah, I don't know. So like I exit out because otherwise I can't write on the screen because it's in the way. And then normally it flashes like back and forth different colors when people say things, and hasn't been doing that. So then I just assumed you were all ignoring me and had no questions. So. All right, everyone's good with that last one now? All right, so we got another calculator one here. And this time we are looking for the area of S. S is the region that is inside of the circle and also inside of 4 minus 2 sine theta. And we're given that these intersect at pi over 6 and 5 pi over 6. So if we want to find the area of S, we are just going to need to integrate this thing. the outer, let's see here. If we just do the so if we can do the area inside of our limacone from pi over 6 to 5 pi over 6, we should just be able to add to that the section that is, what is it, 2/3 of that circle, right? If we're knocking off the pi over 6 to 5 pi over 6 piece. So and what's our function? It's 4 minus 2 sine theta squared d theta. And so that gives us from this intersection point of pi over 6 to here. So that gives us this chunk. And then if we add to that, this chunk coming around here, which is just the circle, that should be, like we said, that's 2/3 of a full circle with a radius of 3. So 2/3 of pi times 3 squared. Was this a calculator one? It was a calculator one. So what do we get there? Everybody good with that setup? Hopefully everyone's good with that setup. That came out to be 24.709. So 1 point, I forgot my 1/2. 1 point for the correct limits, 1 point for the right thing in the integral, and 1 point for the correct final answer. Let's see if my chat thing is working. Okay, nobody said anything. Everyone's good there with part A? Okay. Part B says we've now got a particle moving along our polar curve r equals 4 minus sine 2 theta. So that at time t, theta equals t squared, we want to find the time in the interval 1 to 2 for which the x coordinate of the particle's position is -1. So first thing we're going to do is find the x value of our particle. So that'd be just using x equals r cosine theta, which now I've forgotten what r was. Was it 4 minus 2 sine theta? So 4 minus 2 sine theta times cosine theta. And then we said that the theta value is equal to t squared. So we're just going to replace all of our thetas with t squareds. So that'll give us 4 minus 2 sine t squared times cosine t squared. And we want to know when does that equal -1. And that's what you've got your calculator for. So you'll just graph this function and you'll graph y equals -1 and see where they intersect. And you'll find that they intersect at t equals 1.428. And that one was 3 points. 1 point if you got either one of these two equations, either with theta or with t squared in it. 1 point for setting it equal to -1, and 1 point for getting the actual correct answer. Any questions there on that one? Part B. Yeah, you just plug it into calculator. Graph 4 minus 2 sine t squared, 4 minus 2 sine x squared times cosine x squared, and then graph y equals -1 and see where they intersect. They should intersect at 1.428. And I know I don't have a functioning graphing calculator other than Desmos. Desmos makes it a little unfair, but 4 minus 2 sine x squared times cosine of x squared, and y equals -1. That's a u, not a y. And they intersect for the first time at 1.428. And then after that, you find other places like 2.132, but that's not between 1 and 2, like it said in the problem, right? It said between 1 and 2, so 1.428. Everybody good there? All right, part C. What did part C say? Part C says, for this particle described in part B, find the position vector, find the velocity vector at 1.5. Okay, so our position vector ought to just be x of t, y of t. So that ought to be, and we already have the x component of our position vector. And that's what we'd already written. Position vector should be 4 minus 2 sine t squared times cosine t squared. And then the y component should just be our y value, which would be r times sine of theta. So 4 minus 2 sine of t squared sine of t squared. There's your position vector. And then we want to find the velocity vector at 1.5. Well, the velocity vector is just the derivative of this. So it'll be x prime of 1.5 and y prime of 1.5. And those values you will get from plugging each of these things into your calculator and having it evaluate the derivative at 1.5. And that came out to be -8.072 and -1.673. And that was 3 points, 2 points for having the right position vector and 1 point for the correct velocity vector at the end. Oh, yeah, sorry about that. Yes, parentheses there on your position vector. Any other questions there on part C or any of that one? All right, cool. Those are the 3 I had you guys do last night, I believe. So we got quite a few more on here. Why don't we start here with this one? And we should have time. Do we have time? We at least have time for you guys to do this one. And then we'll probably just go over this one first thing tomorrow. So before I give you guys 15 minutes on this, I'm gonna stop this recording because we're not going to do any more today.